Got it.
So the challenge was to figure out how a suction cup works and also why the larger suction cup is way more difficult to get off a table or off a surface than a smaller suction cup. For example, if I take this suction cup and I stick it to the wall and I stick this one to the wall, that guy just falls right off. This guy's, it comes off pretty easy, but a little more challenging. Then I take the larger guy and I jam that to the wall. This is way more difficult to get off the wall. It takes a lot more force. So really the big challenge is, number one, why do suction cups work? And number two, why is this one more difficult to get off the wall? Well, check this out. Here's what I kind of realized. That one of our challenges was to take the suction cup and press it down. Oh, there we go. Is to take a suction cup and press it down onto a table and listen. And when I did this, when I got in really close and I listened, as I push in, I hear a little bit of air escaping. I hear like a little, so it sounds like air is being pushed out. But check this out. If I slam this up against the board, I can see that chalk blasting out of there. And what's happening is, as this is being pushed up against the board, air is being forced out from underneath the suction cup. So really, I'm going to try that one again. If I do this again, you should see a big blast of chalk. Check it out. Watch this. There's like a big blast of chalk that sprayed out. But then if I carefully remove this, you'll be able to see this kind of a clear area right here where the air was pushed out. That's really important because here's what's happening. Here's what I think is happening. We have the suction cup, and there's no suction force. There's no such thing as a suction force at all. So this whole deal is about air pressure and high pressure and low pressure. So let's take a look. We have this suction cup, and I pushed it, and when I pushed it, the air was forced out from underneath it, and then it was sitting flat on the board. And the reason why that's important is this, is there's no air pushing back this way, but there's a bunch of air pushing this way. And the only thing keeping this sticking to the board is the air around us, the force of the air around us. One of the things that we learned about is that air pushes down on all surfaces in all directions with a force of, we rounded up to like 15 pounds per square inch. It's like 14 point something, but, fine, 15 pounds per square inch. So there is air pushing on the suction cup this way, but there's nothing pushing this way. So the only thing holding this to the board here is the air pushing this way. And if I yank this off the wall and I put it up here and I just let it go, it's going to fall. Because there's an equal amount of air pushing this way, an equal amount of air pushing this way, and an equal amount of air pushing all the way around. So I'm just going to let it go, and it's going to fall. Now, how come it didn't stay there if there's an equal amount of air pushing everywhere? Because there's gravity, and gravity's going to make it fall down to the ground. So in summary, how does a suction cup work? And why is this one harder to get off the table than this one, or this one harder to get off the board than this one? A suction cup works because when you push it up against the surface, the air underneath the cup is being pushed out, and air pressure is pushing in, holding it there. And this guy here is easier to get off the board than this guy because this guy has a bigger surface, so there's more air per square inch pushing down this way and less air per square inch pushing on this guy here. So it takes less of a force for me to pull this off because there's less air pushing, and it takes more force for me to pull this guy off because there's more air pushing. And that's how suction cups work.